This is the page number 20. The first question. What do you mean by utility boilers? Answer. These are boilers that burn coal, oil and natural gas to provide steam to generate electricity. Next question. What are the primary design criteria for central station steam generators and auxiliaries? Answer. There are three main factors: efficiency, reliability and cost. At present, preference is given to equipment reliability to improve station availability. Question. The present day trend is to reduce the size of utility boilers, means to limit the average size of the units between 300 and 400 megawatt or even 150 to 250 megawatt. Why? Again the question. The present day trend is to reduce the size of utility boilers, means to limit the average size of the unit between 300 and 400 megawatt or even 150 to 250 megawatt. Why? Answer. These smaller sized units require less floor space that can be fitted comfortably to the available space and existing utility central stations. They require less erection time. A 300 megawatt unit will take about 6 to 12 months less erection time than a unit twice the size. Economies of scale do not favor large units. Financial risk is limited. Next question. Why are supercritical ones through units preferred to subcritical drum type units for large units 800 megawatt and above? Answer. For very large sizes, the supercritical ones through units are more efficient than subcritical drum type boiler units, means more fuel efficient for the same amount of heat input. Hence, supercritical boilers are favored in those countries, Japan, where the import fuel bill is high and efficient heat utilization overwhelms the higher construction cost of these units. Next question. Why the present trend to prefer ones through boilers to drum type boilers for 500 megawatt and higher capacity monoblock power units? Answer. Monoblock units with drum type boiler for large capacity power plants need a high capacity high pressure boiler drum. These giant boiler drum of a 500 megawatt boiler unit may weigh as much as 200 ton, are considerably larger in dimension and have much thicker wall cross section. The operating experience of these high capacity, high pressure drum type boilers reveals that at varying operating modes, load conditions, in which the unit is shut down and start up too frequently, non-uniform temperature fields appear in the wall cross-section, producing high thermal stresses that bring about cracks of corrosion fatigue in the boiler drum. However, in once-through boilers are no such heavy metal elements as the drum. They are much lighter in weight and can be shut down and start up more rapidly. For these reasons, once-through boilers are recommended for units with the duty supplying semi-peak and peak loads. The next question. Why is the furnace of single housing boilers for 300 megawatt monoblock power plants made of pris- prismatic open shape without constriction? Answer. The purpose is to bring down the average heating intensity of water walls in the flame core zone to a safe level. Question. Is this only way to reduce the average heating intensity of water walls in the flame core zone to a safe level? Answer is no. Recirculation of combustion products drawn at relatively low temperature, means from the convective gas duct, usually downstream of economizer, and reintroducing the same with the aid of fan into the furnace will decrease the heat absorption in the lower radiation zone and stabilize temperature conditions of water walls. Therefore, the average heating intensity of water walls in the flame core zone is reduced. whereupon the possibility of high temperature corrosion is minimized. This portion is very tough. I also need to see again. So next question. Of late, steam boilers with gaslight enclosures are gaining ground. Why? Gaslight water walls ensure a substantial increase in economic efficiency. Second point, it extends the reliability of the boiler units. Heat losses of waste gases are reduced as there is no air in leakage in furnace and ducts. Low auxiliary power consumption in the supply of air and discharge of combustion products. Combustion under optimal conditions with least excess air ratio is possible. This eliminates low temperature corrosions and fouling of heat transfer surfaces. Sixth one, heavy refractory lining is replaced by light heat insulation as a result of which the mass of boiler structure and foundation is curtailed, loss of heat decreased, quicker startup and shutdown. Seventh, easier removal of slag and soot from the furnace by water without risk of damaging the lining. The next question, why the load carrying boiler structure predominantly combined with the building structure in modern high capacity boiler design? Answer, to achieve a considerable saving in metal. For example, such a design of an 800 megawatt monoblock unit result in the saving of 1500 tons of metal. Question, briefly describe the boiler of super thermal power station. Answer, one typical example is the TGMP 1202 boiler of suspended design Russian for a 1200 megawatt monoblock unit. It is a supercharged boiler where the mass flow rate of working fluid flowing by single pass mode in the furnace water was is high as 2000 kg per meter squared second. It is a gas and fuel oil fired supercritical pressure unit where the burners are laid out in two fronts and two tires, and a four burners are used for startup. The furnace carries membrane section of unified width and has large depth so that flames do not leak the water walls, which are of all welded type. The reliability of water walls is enhanced by providing the boiler with a water recirculating system which operates when the load is less than 40 to 50% of the designed load. The horizontal convective duct is laid a supercritical pressure superheated which combines pattern section and two convection stages. We will see the drawings in probably next video. So the next question, why are fluidized bed boilers gaining ground for utility power and cogeneration industries? Again question, why fluidized bed boilers gaining ground for utility power and cogeneration industries? Answer, fuel flexibility. A variety of solid fuels right from low cost solid fuels for convection fossil fuels can be burned. Fuel burned included many types of coals, biomass, petroleum cakes, and other wastes, viz. Anthroxide, mining waste, culm, oil shell, spent shell, tar sands, coal slurries, and agriculture waste using a variety of limestone sorbents. This means flexibility, reactive capabilities of fuel market fluctuations. Second, low installation cost. Modular design allows for lower cost on its on-site installation. Also, modular designs accommodate specific modifications without major redesign cost. Third one is low emission. NOx pollution is minimum and they have the added capability of removing SO2 from the flue gas during combustion. These units are known to operate at the lowest emission profile obtained by solid fuel combustor low particulate emission. Fourth one is high combustion efficiency. Simple design and fuel flexibility allow users to achieve excellent combustion efficiencies as high as 98%. High availabilities in excess of 95% is possible. High turn down ratio and combined cycle. Pressurized fluidized bed combustion technology affords high efficient gas turbine based combined cycle. Minimum building volume. Advanced control system allows accurate control of temperature of combustion products in the furnace, minimizing NOx production, particulate formation, and complete combustion of fuels. Burning hazardous waste. Fluidized bed combustion techniques are particularly useful for hiring hazardous wastes. Their flexibility permits simultaneous combustion of solids, sludges, slurries, and gas in the same unit. These units can attain higher destruction efficiencies at lower temperature for a wide range of waste materials than most other thermal acceleration system. Destruction efficiency is high, 99%, has been reported for fuel containing organic hazards. Co-firing with refuse derived fuel (RDF) as well as convection pulverized coal, fuel, oils and gas is impossible. This is an added bonus of fluidized combustion system using low-cost fuels to meet higher load demands. 12th one is low operating cost and short construction time, low cost electricity and better ash quality. Ash production is non-toxic. That's it now. We will see further in next video. Thank you.